Example 3.3 is looking at a multi-period production model. In a multi-period production model, it's not about how many products we make, it's about when we make them. This is a little bit of a different model to think about, and I don't think it is as intuitive to interpret the sensitivity report. And as a result, what we're going to do is we'll walk through the model itself without really looking at the sensitivity analysis. Now, our input data to this model is we've got an initial inventory of 5,000 soccer balls. We have a holding cost as a percentage of production cost of 5%, and all that really means is that as we produce more units, it is actually going to cost us money to keep them, to store them, to insure them. Let's say you were producing ice cream, you might need to keep it cold in a freezer. If it's 30 degrees Celsius outside, you want to keep that at -10. That's going to cost you money, right? So not only will you tie up your cost of capital in inventory the more you make, but it will also cost you money to keep that stuff safe, secure, and prevent it from going bad. Now in this example here, we've got months 1 through months 6, and we can see that our production cost is going to go up each month. And this is something we could just forecast in terms of our cost of production. Potentially you're looking at maybe a change in the dollar where you're buying your stuff from. Maybe you're looking at an increasing inventory cost. Maybe you've got a contract to supply something that's going to run out. So this is a way of just looking forward to what your costs will be. What we're trying to decide is how many do we produce each month, keeping in mind that we have a production capacity of 30,000 units each month. We can't produce more than that, probably limited by the machine we have. Our on-hand after production is something we are going to need to calculate, and that will change in month 1 compared to months 2 through 6. And we'll walk through that in just a second. What we're also told is that our demand isn't going to be constant each month. It could vary from month to month, and here we have it at 10,000 in month 1, 15,000 units in month 2, 30,000 in month 3, 35,000 in month 4, and we can see how that carries across. Our ending inventory, again, is going to require us to use a formula, and we'll calculate that in just a second. And finally, we have a storage capacity. This is where you would actually need to physically store this stuff, so this is a physical constraint. In this case, we're saying that we can't store more than 10,000 of these soccer balls, but if you were talking about ice cream, maybe you only have so much fridge space in which to keep stuff. The summary of our costs we'll have to calculate in just a second as well. We have our production costs, our holding costs, and then we add it all up together. Now, unlike any of the previous models, in this one here, we're trying to minimize cost, not maximize profit. Walking through some of our formulas here, our on-hand after production. In month 1, we take our initial inventory, and to that we add the number of units we produce. This is the number of units we have available to sell to our customers, our beginning inventory plus what we make. In month 2, that changes. In month 2, we take our ending inventory from last month, which becomes our beginning inventory for this month, and to that we add our units produced. So what we have available to sell to our customers is whatever we had from previous month left over, plus whatever we produced in the current month. Now this formula we can drag across because that stays the same from months 2 to 6. Finally, our ending inventory. Our ending inventory is fairly straightforward. You take whatever you have on hand after production, that's what you have available for sale, keeping in mind this is units, not dollars, and from that you subtract your demand each month, and this will give you whatever you have left over in ending inventory. In terms of our constraints, the number of units produced must be less than or equal to our production capacity. The number of units on hand after production need to be at least as much as our demand, so they need to be greater than or equal to our demand. And then our ending inventory cannot exceed the amount of room we have to store all of that ending inventory, otherwise we would just be making things and throwing them away. Finally, for our production costs, what we have in month 1 is our production cost per unit in month 1 times the number of units produced, plus our holding costs. And our holding costs were told to us in the question as a percentage of production cost. So here we take 5% times our production cost per unit times our ending inventory, and this gives you your holding cost. And then our totals in this month, we just add up our production costs and our holding costs. In month 2, same story, your production cost per unit times the number of units you produce. Your holding cost again is the same thing. It's 5% times your production cost per unit times your ending inventory. And again, we just add that up. All of these things we can drag across to get to our totals, and in this case our total adds up our production cost line, our total adds up our holding cost line, and then our grand total adds across, or we could add down, doesn't really matter in this case. Let's take a look now at what we have to put into Solver. If we click on Data, and we click on Solver, here's what we see. We want to set our objective, which in this case is our total cost, to a minimum. Remember, we're trying to minimize our total cost here by changing the number of units to produce, and that's going to be our decision variable. And here we've got a number of constraints. 1, the number of units on hand after production is greater than or equal to demand. 2, our ending inventory is less than or equal to our storage capacity. And 3, the number of units produced need to be less than or equal to our production capacity. Once again, don't forget to make your unconstrained variables non-negative. You can't store negative units, for example. We're going to choose Simplex LP and then choose Solve. When you choose Solve, you get a window that says Keep the Solver solution. Look for this message down here, Solver found a solution. All constraints and optimality conditions are satisfied. The reports area over here doesn't look like you can do much with it, but this is where you would choose the reports that you want to generate. And finally, you'll say OK. The sensitivity report would show up on the next tab.